Hi, here is my P number, submission date, and video presentation link. And you can click the video presentation link and you can see my video. Here my topic is about DFDS. DFDS is a Danish international shipping and logistics company. The company's name is an abbreviation of Det Forenede Dampskibs Selskab, literally the United Steamship Company. DFDS was founded in 1866 when CF Tiedemann merged the three biggest Danish steamship companies of that day. In this slide, I am talking about overview and company background of DFDS. The Danish shipping and logistics giant DFDS, which was established in 1866, is concentrating on multimodal solutions and strategically growing its network to further solidify its position in the cutthroat European freight market. With 17,000 workers and a Copenhagen headquarters, the firm provides logistical service and ferry connections to more than 20 countries, bringing in DKK 30 billion annually. By 2025, DFDS will have to make changes to preserve its market share in the face of a very competitive industry, especially in the Mediterranean where Irish ferries and other new competitors threaten its hegemony and important routes like Dover-Calais, as seen by its new Spain-Netherlands freight line, which improves connection between important industrial centers while maximizing loading efficiency. The business is reacting by sharpening its focus on its core competency in multimodal logistics, combining road, rail, and ferry services. A key 2025 plan is to integrate its acquisition of Eco-Logistic Turkey Europe transport network, which increases DFDS Mediterranean presence and adds road freight capability to supplement current ferry services. This €260 million transaction, which is subject to EU clearance, puts DFDS to capitalize on Turkey's rising role as a near-shoring hub for European manufacturing, albeit integration expenses and margin constraints in this business will temporarily reduce profitability. Despite project a DKK 1 billion reduction in 2025 EBIT owing to Mediterranean competition and Turkey, Europe-South integration problems, DFDS remains dedicated to its moving together towards 2030 agenda. This includes delivering, decreasing 85% of customer contacts, and moving forward with green transition goals to ensure long-term relations in a sector that is increasingly prioritizing sustainability and operational agility. In this slide, I am talking about product and services and role of supply chain management of DFDS. DFDS is a prominent participant in European logistics, providing a wide range of services such as freight, transport, passenger travel, and supply chain management. Its good transport service include RO-RO, roll-on, roll-off, and ro-pax ferries, which allow for efficient cargo transfer throughout Europe. These boats are intended to expedite the loading and unloading operation, resulting in shorter transit times for industries such as automotive and manufacturing. For passenger services, DFDS operates ferry crossing between important locations such as Dover-Calais and Copenhagen-Oslo, providing convenient travel choice such as business meetings and short cruises. These routes are equipped with contemporary facilities to enhance the convenience for travelers. In terms of supply chain solution, DFDS specializes in third-party logistics (3PL) and fourth-party logistics (4PL), providing customized service such as transportation, storage, and temperature control shipment for perishable items. DFDS guarantees flexibility and efficiency in transferring products across areas by using multimodal transportation, which includes road, rail, and sea. These techniques not only help organizations save expenses, but it also improves supply chain dependability. DFDS experience in cold storage and transportation assists businesses that require precision handling of sensitive items such as food and medicines. DF's integrated services continue to ease complex logistical difficulties while keeping a focus on innovation and client satisfaction. In this slide, I am talking about conceptual framework on the SUR model. The SUR Supply Chain Operation Reference model offers a systematic framework for analyzing and improving supply chain performance with six major components: plan, source, make, deliver, return, and enable. This approach can help DFDS, a prominent logistics and ferry firm, analyze and optimize their operations. During the plan phase, DFDS forecasts demands for both freight and passenger services, plans ferry timetables, and coordinates logistical activities. During the source phase, the corporation purchases critical resources such as boats, fuel, and other operational supplies required to perform its services effectively. While DFDS does not manufacture actual things, the make component remains important in terms of service creation, which includes strategic route planning, fleet maintenance, and ensuring boats are ready for deployment. The deliver phase entails overseeing the actual ferry operation to ensure the timely and dependable conveyance of goods and passengers. In the return phase, DFDS manages reverse logistics, which may include handling damaged items, unused freight capacity, or rerouting service as necessary. Finally, the enable phase emphasizes DFDS investment in cutting-edge technology, including real-time tracking systems, which boosts supply chain visibility, efficiency, and customer satisfaction. By aligning its operation with the SUR model, DFDS can provide a high level of service while continually increasing supply chain performance. Here I will talk about analysis of three key processes of DFDS using SUR model. And here is the plan. DFDS demonstrates a strong planning capability through its data-driven approach to demand forecasting and inventory visibility. By leveraging historical data, seasonal trends, and real-time analytics, the company enhances its ability to predict customer needs and allocate transport and storage resources accordingly. The planning process primarily follows a pull-based strategy in its logistics services, responding to actual customer demand rather than forecasted volumes. However, its ferry operation, particularly passenger services, often rely on a push strategy, using forecasted data to schedule routes. Digital platforms provide customers with visibility into their shipments, enabling better inventory coordination. The application of the theory of constraints is evident in DFDS planning strategy as the company continually address capacity bottlenecks such as limited ship space or port delays by dynamically adjusting schedules and prioritizing high-value routes or customers. Here I'll talk about source. The sourcing function at DFDS is marked by strategic supply relationship, long-term partnership, and robust contracts management. The company collaborates with key suppliers such as shipbuilders, port operators, and third-party logistics providers across Europe to ensure high service quality and cost control. DFDS maintains a strong contractual agreement that includes performance expectation and risk mitigation clause, particularly valuable in a sector sensitive to disruption like port strikes or fuel price volatility. The use of transaction cost economic helps explain DFD's sourcing strategy by evaluating the cost of outsourcing versus in-house control. The company has chosen to own and operate key infrastructure, such as ferry terminals, where it leads to better efficiency and reduced coordination costs. In this slide, I'll talk about deliver. DFDS delivery capabilities are optimized through technology-enabled logistics and a focus on sustainability. The company uses digital tools for real-time route optimization, load planning, and deliver tracking, helping reduce empty miles and improve fuel efficiency. Customer satisfaction is supported by reliable service, transparent delivery windows, and user-friendly tracking portals. Additionally, DFDS is increasingly integrating reverse logistics service for its B2B clients, allowing for different returns and reuse of resources. The company's emphasis on lean logistics is clear in its efforts to eliminate waste throughout the delivery process, from route planning to fuel usage and packaging materials. Investment in electric vehicles, hybrid ferries, and carbon reduction initiatives reflects DFD's alignment with environmental goals and its drive to offer efficient yet sustainable logistics services. These improvements directly support DFDS' reputation for timely, reliable delivery while also addressing cost and environmental performance. Here I will talk about a major challenge for DFDS, and also I will describe about fishbone analysis. A major challenge for DFDS is adapting to new regulation, from regulation on sulfur emissions and ballast water to goals for the reduction of greenhouse gases. The list of demands on the industry keeps growing. Currently, one of the biggest challenges is keeping up with regulation, says Paul Hodder, Director of Environment and Sustainability at DFDS. From regulation on sulfur emission and ballast water to goals for the reduction of greenhouse gases, the list of demands on the industry keeps growing. Regulation is, of course, absolutely necessary for the protection of the planet, Hodder adds. The issue arises when legislation does not consider all the moving parts of the climate equation. For instance, regulation put in place to reduce the sulfur emission of ships may improve the air quality of coastal regions but could be viewed as counterproductive in the combat against global warming. This is in part because sulfur dioxide emissions actually have a cooling effect on the climate. These are plenty of examples like these that underscore just how difficult it is to regulate an issue with these many moving parts. Take the discussion surrounding bioethanol and other biofuels. While those fuel types emit almost as much CO2 as fossil fuels do, the way they are produced makes them a net positive in terms of emissions, say Hodel. The idea is that the organic base of biofuels stems from plant matter, which has absorbed more CO2 during lifespan than it emits when burned as fuel. Hodel continues, and yet these calculations don't factor into the way we currently measure carbon emissions. This only goes to show that while it is crucial to gear companies to be able to accommodate the ever-changing regulatory landscape, it is equally important to be mindful of the quality of regulation if real progress is to be made. And about fishbone analysis, limited green technology adaptation. This showed that DFDS could not be using all of the available eco-friendly technology into their operation. This could consist of alternative propulsion solutions for ships, include electric or hybrid propulsion system, advanced hull design, waste heat recovery system, or better route planning are examples of energy-efficient measures. Carbon capture technology, alternative fuels, or exhaust gas cleaning systems. Scrubbers are examples of emission reduction technologies. Talking about process, inefficient fuel use increase emission. This suggests that operational inefficient results in increased fuel use and as a result elevated emission. Place to investigate suboptimal vessel speed, fuel consumption skyrockets at higher speed, ineffective route planning, fuel consumption rise for longer or unfavorable weather routes. Going through materials, high dependency on fossil fuels, this denotes a high reliance on conventional fuels such as diesel or heavy fuel oil, which are important source of air. This dependence may result from lack of infrastructure in important ports. There is a dearth of infrastructure for alternative fuels such as LNG, ammonia, and hydrogen. And talking about technology restriction, the present inability of alternative fuels to provide the energy requirement of huge ships people, lack of training on sustainable methods. This points to a lack of knowledge and training among DFDS staff members on sustainable methods. This might consist of absence of training initiatives, lack of through training courses on environmental law, fuel efficient operation and modern technology, limited awareness, crew members' lack of understanding of the significance of sustainable practice and the effect their action have on the environment. In this slide, I will talk about recommendations for improvement from an operation management perspective. They have grown in both size and revenue, and they will now unlock the value of their expanded network and drive skill benefits. They will accelerate organic growth by leveraging our comprehensive product range and building of products to meet customer demand. They have expanded geographically and are present in more than 20 markets, and they will benefit from new growth markets while they continue to develop their strongholds across Europe. In sum, they will do this by driving organic growth with broader geographic and product reach, enhancing a competitive cost base, benefiting from high growth markets, continuing to develop strongholds. In recent years, They have grown and expanded our network, and with growth also comes complexity. They will streamline and simplify the way we work and operate and continue to grow their business in a profitable way. With standard process, they will have better data transparency across their network, which is a prerequisite for digitalization. This will help them improve to their workflows, scale benefits, and become more efficient. In sum, they will do this by standardizing their operation procedures to enable data-driven decisions and automation, reducing complexity to secure efficiency and enable future growth, ensuring local commercial autonomy supported by globally aligned products and back-end services. They will accelerate their digitalization to meet customer demands through digital self-service and providing more transparency on their sea and land transport. They will optimize their work process through optimization, enhanced planning, and prediction capabilities while also adapting faster to new technology. In sum, they will do this by transforming the way they connect with their customers, reshaping the way they operate, developing a future-proof technology platform.